Module 4, Lessons 33 and 34, Inequalities. Our learning targets. I understand that an inequality with numerical expressions is either true or false. I understand solving inequality is answering the question of which values from a specified set, if any, make an equality true, and I can recognize that inequalities of the form x is less than c and x is greater than c, where x is a variable and c is a fixed number, have infinitely many solutions when the values of x come from a set of rational numbers. We are going to start by solving problems, and we're going to figure out what value or values the variable has to represent for the equation or inequality to make our number sentence true. And then we're going to talk about what values or value the variable has to represent for the equation or inequality to make our number sentence false. So we're going to start with y plus 6 equals 16. So this is an equation, and we are going to solve for y. So we're going to subtract 6 from both sides. So y is going to be equal to 10. So our number sentence is true when y is equal to 10. And our number sentence is going to be false if it is any other number than 10. So in this equation, we can only use the number 10. Any other number is going to make it false. Our next one is y plus 6 is greater than or equal to 16. And this is an equality. An equality is going to have a greater than, less than, or greater than, equal to, less than, and equal to. So instead of just an equal sign, you're going to have something that looks like this, or it can look like that, or it might just look like that, or like that. That's what makes it an equality. So we're still going to start by solving for y. So we're going to subtract 6 from both sides, so we can get that y has to be greater than or equal to 10. So our number sentence is true when y is any number greater than 10, and the sentence is false when y is 10 or any number less than 10. And now we're going to do y plus 6 is greater than 16. So we are going to solve for y. So we get y is equal to 10. So our number sentence is true when y is any number greater than 10. And our number sentence is going to be false when y is 10 or any number less than 10. So now we're going to have 3g is equal to 15. This is an equation. So we're going to solve for g, divide both sides by 3. So g is equal to 5. So the number sentence is true when g is 5, and the number sentence is false when g is any number other than 5. So now we're going to have 3g is less than 15. So now we're working with an inequality. We're going to solve for g. So g is less than 5. So our number sentence is true when g is any number less than 5. And the number sentence is false when g is equal to 5 or is greater than 5. And now we have 3g is less than or equal to 15. We're going to solve for g. So g is less than or equal to 5. So our number sentence is true when g is 5 or any number less than 5, and the number sentence is false when G is any number greater than 5. So for these next two problems, we're going to be using this set of data on your screen, and we are going to determine if any of these numbers make the equation or inequality true. So our first one is m plus 4 is equal to 12. We're going to solve for m, so we're going to subtract 4 from both sides. So m is equal to 8, and we can see that 8 is in our data set, so we're good. And now we're going to have m plus 4 is less than 12. And we're going to solve for m. So we have m is less than 8. So it can't be equal to 8. So it can be any of these three numbers because they are all less than 8. So in order to make this inequality true, you can use 0, 3, and 5 because those are less than 8. Now we have f minus 4 is equal to 2. So we have to solve for f, so we're going to do the opposite of subtraction. So we're going to be adding 4 to each side. So f is equal to 6. And if we look at our data set, we don't see that there's a 6 in it. So none of the numbers in this set will result in a true number sentence. And our last one is f minus 4 is greater than 2. So we're going to solve for f. So we have f is greater than 6. And if we look at our data set, we have 10 and 14. So we can use 10 and 14. And we also have 8. So there are 3 possible numbers that can make this number sentence true: 8, 10, and 14. So now we're going to practice writing inequalities and graphing inequalities. So our first example is Caleb has at least $5. And I'm going to use the variable C to stand for Caleb. And we know he has at least $5. So he's not going to have anything less than $5. So C is going to be greater than, but it can also be equal to 5. So that is our inequality, and now we're going to graph it. So on your screen, I have drawn a number line, and we're going to plot a point at 5, and it's going to be a closed circle, because a closed circle, when we are graphing inequalities, stands for equal to. And we know that Caleb has at least $5, where equality with C is greater than or equal to 5, so it's going to have a closed dot. And then we're just going to draw an arrow, and it's going to be an arrow because it can go on and on and on. It can go past 8. As long as it is greater than or equal to 5, it is a possibility. So Caleb could have $200. He could have $1,000. As long as it's above 5 or equal to 5, you have the correct answer. So now we have Tariq, and Tariq has more than $5. So I'm going to use T as our variable for Tariq, and he has more than, so that's a sign for greater than 5. So our inequality is T is greater than 5, and now we're going to plot that on a number line. So I've drawn our number line. So we're going to go to 5, and we're going to plot our point. However, this is going to be an open circle because it is not equal to. It's just greater than. So that's an open circle. And then we're going to draw our arrow to show that he has more than $5. So he could have $1 million. Who knows? All we know is that he has more than $5. And now we have Vanessa, and Vanessa has at most $5. So I'm going to use V as our variable to stand for Vanessa, and she has at most $5. So she can't have anything over $5. So it's going to be V is less than, but she has at most $5, so that tells us equal to. So V is less than or equal to 5. And now we can plot our point on our number line, and because it's equal to, it's a closed circle, and to show less than, we're going to draw our arrow going that way to the left. And lastly, we have Lynn, who has less than $5. So I'm going to use the variable L, less than 5. So our inequality is L is less than 5. So now we can plot our point on our number line. It is an open circle because it is not equal to, and then we draw our arrow. So now we have a story problem. So Kelly works for quick oil change. If customers have to wait longer than 20 minutes, so key information, longer than 20 minutes for the oil change, the company does not charge. So it is free. And the fastest oil change that Kelly has ever done took 6 minutes. So the fastest is 6 minutes. Show the possible customer wait times in which the company charges the customer. So we're going to use the variable x, and because we have two numbers, we're going to put x in the middle. So then we're going to have our inequality signs going this way to show the two numbers. Our smallest number is 6, so that's going to go on the left. And because the fastest is 6 minutes, 6 can be less than or equal to x. And then if it's longer than 20 minutes, it's free. So now we have 20 minutes, and x can be less than or equal to 20 minutes. So this is telling us that we have a span between 6 and 20, and now we can place this on a number line. So I've drawn our number line, so we're going to start with 6, and because it is less than or equal to, it is a closed circle. And then we can do 20, and 20 is also less than or equal to, so it is a closed circle. And then we are just going to connect our dots. And this shows the inequality that an oil change can be anywhere between 6 and 20 minutes before the customer does not have to pay for it. And that's it. Now you can go complete the problem set.